from before, we know that equations of motion, which are in x direction in horizontal motion, V2 is equal to V1 plus A multiplied by T. V2 is squared is equal to V1 squared plus 2AX. X is equal to X naught plus V naught X in X direction, T plus half A T squared. This motion in X direction, look, the velocity in X direction, also the acceleration in X direction. It is AX. It is the acceleration in X direction. We have the same equations in Y direction. Vy2 is equal to Vy1 plus Ay, which is G, the acceleration due to gravity. Okay, multiplied by the time. The velocity has a direction, so we have Vx and Vy. The position Y, we have a position X. We have X and Y. We have acceleration in X direction, which is Ax, and we have an acceleration in Y direction, which is G. And we need to know where is our positive and negative directions in each problem. The time is the same. In X direction or in Y direction, we have the same time. The time is general here. Okay. So these are the three main equations of motion. And also we know the position vector from before, which is R as a vector, is equal to X component in X direction plus Y component in Y direction, J direction. Also, we know that there is a velocity vector, which is Vx in I direction plus Vy in Y direction. And also, we have an acceleration, which is Ax in X direction and Ay in Y direction. We have in Z direction, but we will not talk about it. Okay? Now, these are the main tools we need to use them in this problem. The projectile motion. Let us talk about projectile motion. If I throw an object with zero angle above the x-axis, above the horizon, like just this eraser, like this, it's a projectile, but with angle equal to 0 with x. It is a motion in one direction. What if I do this? It's a projectile motion with angle equal to 90 degrees. It is a motion in one dimension, as you see. Look. But what if I have an angle? When I throw this like this, I have an angle like this. I have angle theta or alpha. You can name it as you like. In the notes, I name it alpha. Okay. So the motion, the initial motion for my object with angle alpha and with velocity v0. This is at time equal to 0 and t equals 0. So the velocity, it is a vector quantity, and alpha, it is alpha at time equals 0, which is alpha 0. I named them by 0 because later I have different values for them. For example, this is my alpha, this is V0, and this is alpha 0. You can see later, if my motion like this, if I name this point, for example, 1, then I have another angle. I have alpha 1 and V1. If I am at the top of my motion, the maximum altitude here, I have this velocity. I can name it V2, and I have also alpha 2. What if I am here? I have this velocity, which is the tangential direction. This is V3, for example, if this point is V, and this is the X. And this is the angle, alpha 3, or be careful. When we need to measure any angle, we need to measure it counterclockwise, like this. What if I have to be the same, the end? What if I have this angle? I need to measure my angles from the positive x direction. This is angle, my angle. What if my angle is here? My vector. Yes, you're right. You can tell me this is minus maybe 60. But in our solution, we need to measure it. We need to measure this angle. How much is this? It is 360 minus 60, right? So it is 300. But if you need to find sine minus 60, it is the same as sine 300. The sine of this angle is the same of this angle. It is negative. The sine is the y component. Also the cosine. Cosine minus 60 is equal to cosine 300. So it is okay to measure the angle from the negative side, from the negative direction, but you need to put in your mind, this is our angle. Any questions about the angles and the angle measurement? And be careful until today, until now, and the first midterm exam, we need to deal with angles in degrees, not in radians. Okay? Now, in the projectile motion, we need to consider our origin. This is our origin, the starting point of our motion. The second thing, we need to consider the positive and the negative directions in x and y. Maybe we can measure, or we can use, this is the positive direction upward, and this is the negative direction with respect to y. For x, we can consider this. This is the positive and this is the negative direction. Okay? The third point, we don't have any friction force due to the air. Okay? Our experiment is an ideal space. But in general, to know that if you are athlete, for example, you play some sport and you study in physics, this is the projectile motion for a ball, for example, or something. Be careful. Ideally, or without air friction force, there is a symmetry between the two parts of the strip, okay? But with air friction force will be like this. There is a friction force in y direction and in x direction. This will reduce the range. I will talk about it. And it will reduce also the highest point. Now, let us understand some things about the x and y direction. Now we know the positive and the negative direction in each direction. Okay. Now for y. Let us start for y. The velocity for y is changing. You can see when I throw this, the velocity come to be 0 at the highest point like this. If I start, for example, by 10 upward, here it will be 8. Then, for example, 5, 2, 1. At this point, the object cannot go upward. So its velocity here is equal to 0 at this point, at the highest point. Then it will start again going down as a free fall. Then its velocity will be again 1, 2, 5, 8, then 10, but with the opposite direction. Because we don't have any friction force, then at each altitude we have the same velocity. This is the y motion. This is the velocity. What about the acceleration? Okay, the acceleration, which acceleration we have in y direction? Who can tell me? It is there. Isn't that question? What is the acceleration we have? It is g. It is the acceleration due to gravity. Just, and it is downward. We have g, always downward. Because of that, g is negative. The velocity when I am going up, it's positive. The velocity when I'm going down, it's negative. Just like the previous example that yesterday. Okay, another important thing. When I was new place, I answered it the wrong way. G is always constant. When I am going up, G is G. It's constant. It is negative 9.8 meter per square second. There is always G. How much G at the top? How much G here? The velocity is 0. But G, it is still the same. To tell you, when I am in your place, I answer it to be 0, but it's not 0. Because of G is always constant, then the object will be allowed to return its motion direction and go down and increase its velocity again. So G is constant always in my equations. The altitude, y. I have, this is y0, the 0th level. This is y max. Y max. At y max, the vertical velocity Vy is equal to 0. Okay? Be careful about this point here. This is all about y, I think. What about x? We don't have any friction. X, we don't have any friction force. We don't have any force will increase the velocity in x direction. Also, we don't have any force will decrease the velocity in x direction. So, the velocity in x will be constant. So, Vx will stay the same at all the range. The maximum x distance, we can name it range. We don't have any acceleration in x direction. Ax is equal to 0. Ax equal to 0. Ax equal to 0. Ax equal to 0. Sorry. So we don't have this term. We don't have this term. We don't have this term. Okay. We have the equations now in x direction. V2 is equal to V1. V in x direction is the same. V2 squared is equal to V1 squared. It's the same equation. This and this. X equal to x naught plus Vt. V in x direction. It will not change. It is the simple velocity equation relation, right? Now, we will use the position vector, the velocity vector, the acceleration vector to solve any problem. Okay, R in x direction, x, where is x? This is x. So we can put it x equal to x naught, and x naught at this point, you can assume x naught equal to 0 and y naught equal to 0 if you like. But I will keep it here. So I have R is x naught plus v naught t in x direction. This is Vx. What about y? I need to put this equation. Okay. This is y naught plus vy naught t plus half gt squared. All of this in j direction. Okay, what is vy and vx? It's simple. You know that from before. It is vector operation. This is v naught. This is alpha naught. What is x? Naught. It is v naught cosine alpha naught. What is y naught? Sorry, this is v. This is v x naught. This is v y naught. It is v naught as a magnitude. Sine alpha naught. I need just to use sine and cosine. This is v naught at here, at this point. For x, it will stay the same. It will not change its magnitude. For y, it will change its magnitude. Vx will stay the same. V naught cosine alpha naught. Vy, I can use this. It's okay. I can use this. It's okay. Vy is, for example, keep it Vy. J. What about the acceleration? What is the acceleration in x direction? I will open the chat. And okay. What is the acceleration in x direction, online or offline? We just talked about it. It is 0. What is the acceleration in y direction? In y direction, it's just g. This is the acceleration vector. We have everything to solve any problem now. Any question about projectile motion? We will start solving examples. The different examples, even if you look in the textbook, you have a zero approach, you have a general approach, you have a vertical approach. They mean by that if we change theta, alpha. If alpha is equal to 0, this is a zero approach. If alpha equal to 90 degrees, then this is the vertical approach, and so on. We will solve it in general, and we can solve any problem. Okay, if you look at page number 9, there's the first example. I guess before that, we can use the Pythagorean theorem in page number 7 to find the distance, also to find the speed, and to find alpha. Alpha at any point you can just don't. Yes, this is for the next chapter. Now we're talking about the projectile motion. We have the notes.